episode, we're going to make the mechanical Speedo run off a GPS.
So what we're going to do is we're going to spin the factory gauge with an electric motor, and we're going to use an Arduino to control how fast that motor spins. And the Arduino is going to be fed by a GPS, so we know exactly what speed we're doing. So we just draw a little diagram of what I'm planning. So the gauge is going to be connected to a motor. Okay, that motor needs an earth, and it also needs 12 volts or thereabouts. Actually, I'm probably going to feed it less than 12 volts because it's a 4,000 RPM motor, and I only really want it to turn at 2,000 tops. So the gauge, apparently, according to the internet, spins at 1,000 RPM for 60 miles an hour, 120 on the clock, I think, or thereabouts. Anyway, I don't particularly want to overspeed it, and for the moment at least, I won't be doing 120 in the car anyway, so that's all fine. So it's never going to get up to 4,000 RPM anyway. So there's going to be an Arduino, and that's going to talk to the motor on a PWM pin, so pulse width modulation. And what that means is either that signal is on or off, and the amount of time in a percentage, I suppose, that it spends on is the percentage of power that the motor gets. So if you have 0, the motor doesn't spin. If you have 1 all the time, then it spins full power. If you do 50% of the time, then it will spin at half power or half speed. So the Arduino is going to control that. And also, coming from the motor, we get a feedback, so the motor can tell us how fast it's spinning. That might be useful for some fine tuning. So perhaps the voltage isn't quite right, and it's not spinning as fast as we expect it to. It can get a readout, or the Arduino can receive a readout from it. It can compare that to the GPS signal and make an adjustment, potentially. So the Arduino is going to be plugged into a GPS. And again, that's a serial connection, so we've got 2 wires in and out there, and that needs power. It's 5 volts, which I can pull from the Arduino. 5 volts, and also an earth, which can come from the Arduino as well. Now, the Arduino itself wants a 5 volt signal, or a 5 volt power supply, which we're not going to be able to get from the car. Well, not really anyway. Certainly not from the alternator, which is currently pushing out about 14.5 volts. So what we're going to do, we have a positive and a negative side, and we're going to make a power regulator. Okay, so on this side, let's say we've got 14 volts over here, because that seems to be what it's pushing out. All right, so if we feed that into the power regulator and we earth it as well. So the power regulator is, we're going to set that to step down 14 volts to 5 volts, and we want that to be relatively stable. So first off, let's put some polarity protection in there, because I'm an idiot and I'm likely to wire it up backwards. So we'll put a diode in here. Okay, so what that means is if I wire it up backwards, it just won't work. So that's fine. The other thing is we don't want any large spikes going into this thing. I'm not sure how robust they are. You might get spikes from the alternator. It's certainly not going to be the same voltage all the time. So what you can do is you can put a diode in here and connect positive to negative, essentially, and that is called a TVS diode, and that will smooth out any big spikes in voltage. The other thing we can do is put some ferrite beads in here, and that will smooth out any noise. Again, we don't want to upset the electronics on the power regulator. So that's going to power the Arduino, and I think we're going to do, I think the motor probably isn't so sensitive. We do need a power regulator because I want to step down the voltage. I don't even want it 12. I want it 10 volts, say. And that's going to need an earth as well. So we're going to feed that again with the 14 volts. We're going to earth it. And I think I'm going to put the TVS in as well, and the ferrite beads, for no real reason other than I can, and they might as well be the same. So let's have a go at making that then. So I've been on the internet. I've bought some little power regulators. So this is an LM2596 DC to DC, and it's essentially that chip there that that controls the regulation. And we've got a little screw on here that'll that we can set the voltage on. So you wind it down and it'll go, voltage will go up, wind it out and the voltage will go down. So we've got 2 pins on the left for the incoming voltage and 2 pins on the right for the outgoing voltage. What else do we have? We have the TVS diode. So that looks like that. So he's going to sit between there. And then we've got some ferrite beads, which are these guys, to smooth out any noise coming from anywhere. So they're going to go like that. And then we've got just a normal diode, which is going to go that way round, like that. And that will stop me plugging it in backwards. And then on the right hand side, all we want is some wire to connect up to the motor or the Arduino. So I'm going to try and solder that together now. My soldering's not the best, but it's the best I can do. Alright, so I'm feeding this 12 volts from a source on my desk. So if we look at the voltage coming in, we've got 12.1. And we get a decent connection. So that's going to continue all the way to the board, slightly less. And on the outside, currently got very slightly less. So what we want to do is find a way of locking these together. Oh. So on the outside, we've currently got 11.1 volts. So we want to screw that out until it starts moving. Got to turn this quite a lot. So we'll use this one for the motor, and I'm going to give it 10 volts. In fact, no, I'm not. I'm going to give it 6 volts. So our 4,000 RPM at 12 volts is going to be more like 2,000 RPM at 6. Okay, so that's bang on 6 volts. So that will feed our motor.
A few minutes later.
So rinse and repeat for the Arduino power supply, and that's 5.01. Great. EM gauge is fed by a spinning cable, which usually attaches to the gearbox, and we've done away with that gearbox. The BMW version doesn't do that way. It's all electronic. So the plan is to connect an electric motor to the cable, and in order to do that we need a gearbox, because the motor doesn't really like spinning at very low speeds, whereas the early part of the gauge is really quite slow. So the other reason is we want a bit more torque going through the cable, so gearing works for that as well. So the plan is to 3D print this. The grey part there is just a housing, and it's got a 7/8 thread on the top for the cable, which screws right in. So the cable then attaches to that little axle or that little drive shaft in blue there, and that is driven by the green spur gear. The spur gear is driven by the pinion gear, which is the red one, the smaller one, and that has the motor bolted to the bottom of it via the plate at the bottom that you can see there in blue. At the top we've got another hole, so there's going to be a encoder, which is a device that just detects revolutions, and that is also connected to the red pinion gear. Parts printed. So there was a slight update to the main housing for this side door here, or this side panel. I think I'm going to put one on the other side as a door. I do need access in this way to get to these grub screws to hold the encoder in. So it may have to be removable. The reason I want it enclosed is because I'm going to stick some grease in it, and I don't want it flinging everywhere, but we'll see if that's a problem. So also in the main housing we have a skateboard bearing sitting in there, and that is going to sit, this shaft is going to go through there like so, and then connect to the cable like so. So that will spin that. The spur gear is going to get attached like that. I do need to press this in carefully, so I'll do that off camera. And then we also have a bearing in the motor plate, and that is so that the shaft has got support on both sides, stop it wobbling around and moving about. So the spur gear, the pinion gear has got two grub screws in it, one to hold it onto the motor and one to hold it onto the encoder, so that lives in there like that. And that's all that's holding that in. I may have to put a grub screw in here, or something, or I may just glue, oh, sorry, it's actually in here, isn't it? So I may have to just glue it in actually. I'm hoping it doesn't start moving, we'll see. If it becomes a problem, I'll probably just glue it. So let me put that together, and then we'll stick it in a car and see what happens. So this is how that's turned out. Pretty well, I think, really. we've got the 2.125 ratio gears. The pinion gear goes from the motor to the encoder for getting the accurate speed, so that we can allow for drag on the cable and things, which may change, which is why that's important, or wear in the gears or whatever. It seems pretty strong. I think that would probably do it, but I am going to print it again with some harder filament. So this is my test bed for the Arduino. This is called a breadboard, and that is an Arduino Nano. I did use a full-sized Uno to begin with, but I want the final solution to be pretty small, so I've got a few of these now as well. I did put an LCD on it, but that has stopped working, annoyingly, and I wonder whether I've done something to break it. It was working for a while, and then it just stopped, so either I've done something to the code or I've done something to the screen, but never mind. It's not the end of the world. It has added quite a lot of complexity, which I probably could have done without, but anyway, maybe I'll get another LCD and try it, but it doesn't really matter. So we've got various ins and outs, and we've got the connection to the GPS. Obviously we can't run this in the car, so I need to convert it to an actual PCB, which looks like this. So I do have the plug for the screen on here, and we've got various connections to the power and to the motor and the encoder, and it's working pretty well. So what I can do, if I bring up Arduino IDE, so this is the serial output of the Arduino, and it's telling us that we're in GPS mode. We have two modes, GPS and test. It's giving us the speed that we've asked for, or the GPS has asked for. We've got the true speed, which is coming from the encoder, essentially the RPM from the motor. We've got PWM, which is the pulse width modulation signal being sent to the motor. Essentially that's a number between 0 and 255, 0 being nothing, 255 being full power. We have a pot file, or sorry, a pot potentiometer, which has a value, which is basically just this little guy on the board, that one there, and that means we can fine tune the RPM to speed calculation. Just gives us some fine tuning, which is useful. There's the factor, which is also for fine tuning. We've got a GPS signal, so we can see that or a GPS status. So that tells me that the GPS is okay, and you see we're getting this very minute speed reading from the GPS. That might be because it's a bit cloudy today. It should really say 0. But what we can do, we can put this in test mode, like so, and then we can give it a speed such as 60 miles an hour. And then we have 60 miles an hour on the gauge. Up it to 80, back down to 40. Not bad, eh? It's a little bit wobbly, but I think perhaps some grease in the gearbox and actually securing it would probably help with that. But for the moment, that's pretty good. So what I need to do now is 3D print a housing for this. And then we can try it in the car. An enclosure for the electronics as well. So that is a little plug for the GPS antenna. We've got some power cables coming out this side, and the motor wires coming out this way. I do need to make an end for it, but that's not a big deal. So that's what's going in the car, and we've got some little tabs on the end to secure it to something. Not sure where it's going yet, but we'll see where this thing wants to go. Usually it used to be under the car, obviously, so it's quite long, but we'll see when we get there.
Well, hopefully you can see the the phone and the